Good afternoon, ladies and gentlemen. I'm happy to welcome you here to the final presentation of our Austrian Tunnel Safety and Security parallel session. Our next presenter is Michael Kompatscher from Switzerland. He's Managing Director of the Hagerbach Test Gallery, and he will show us a very impressive presentation of a research project they're involved in with set of tests which they also did in their test facility. So I'm really looking forward now to give the floor to Michael, and I wish you an interesting presentation now.
Hello to everybody. It's a pleasure to give the presentation about this recent investigation research topic we had here in our Hagerbach Test Gallery. Okay. The study was building up on already an earlier research topic we had about electric vehicles, where we already saw in our test gallery that there is a difference between known vehicles and battery-driven vehicles because of the different emissions. And we wanted to have a closer look at this. So let me give, first of all, credit also to my co-workers from Amstein Waltert, who led the project. This was Lars Mellert and Urs Welte, but also the experts involved from the EMPA, Dr. Duchschmidt and Marcel Held, as well as my co-worker Michael Hermann, and the experts that consulted us from the SETI, Mr. Tesso and Lea Nashev. The whole report is published and can be downloaded from the website of the Swiss government. It was a funded project by the Swiss government. Now about the motivation that was driving this expertise. We were looking forward to a scientific analysis of the realistic fire tests and to have a dedication in measurement. So it was about an experimental proof, an empiric approach, and we wanted to deduce the impact to the underground trafficated infrastructures based on the influence of electric mobility. And from this, we wanted to derive technical and organizational measures to prevent or to mitigate potential damages. And this was a new method, and starting from a worst case approach. We could not study all the different topics, but the target was really to go for a worst case approach in this. So our hypothesis was the emissions of an electric vehicles in an underground infrastructure, traffic infrastructure, they lead to contaminations that have long-lasting effects on the operation and safety. And we wanted in the experiment to see if this is true or not, and to confirm this. So the approach we had, well, let's reduce the whole investigation from compared to traditional vehicles. We have also the electric vehicles, and see the main difference. Standard things around are the same, is the battery itself. So let's focus on the batteries, investigate a single module. Let's have a completely new battery on this, make sure that we can scale the results then back to a realistic vehicle to the right level. And in this case, it was concentrate on the fire emissions, not to other topics. So how to approach this? We took a single battery module and mechanically damaged this to force and to cause the thermal runaway. The battery, the test material we took was a module of 4.15 kilowatt hours. You see a picture of this type of module. We bought a new battery of a pure electric vehicle. And the typical temperature where the thermal runaway starts is about 210 degrees centigrade. We forced to start the thermal runaway with a special method by the use of pyrotechnology. So we used basically the battery, put a plate on, and in a very, very controlled way with an explosive, we caused two knives to penetrate all batteries at the same time. So we had the maximum destruction or causing of the thermal runaway of the batteries. And then we investigated this in an environment as infrastructure and wanted to see how the deposits are, be it on the surrounding, be it on the wall of the tunnel, in a closed environment, or if there are protective clauses, what does this mean? Then we wanted to analyze also the effect of the emissions or the chemicals in the smoke to the extinguishing water and also to the cooling water at the end to get rid of the battery itself. We also wanted to see in an open ventilated tunnel how the propagation of these potential emissions or dangerous chemical emissions taking place. We wanted to do this in a quantified way. In the first experiment, we already saw that we have a lot of emissions. We did not quantify them. And we wanted to see also how long the persistence of these emissions, potential dangerous emissions, toxic emissions are. And of course, we make the material analysis also post-mortem. And this is what I want to present you today. The environment that we used, we were here in the Hagerbach Test Gallery. We selected two areas. One area was a tunnel piece where we had a volume of 250 cubic meter, and we closed this completely. There was no mechanical ventilation. We just had then a sucking machine kind of that was filtering out the emissions afterwards and helped to clean out before we released this via our standard tunneling ventilation system outside. Important was also the volume we selected was a scaled volume because we wanted to have a reference toward a larger environment, like in a parking garage, for example, in a closed thing. And the release rate known from the battery if you fully destroy them. So we put the module we used is a 1/8 of a full battery from a vehicle. This corresponds also to 1/8 of a parking level. So it's about 250 cubic meter where we wanted to study the emissions in this environment. This was the closed room scenario where we made two tests, and the other test was in another sector of the gallery where we have also controlled ventilation. So we could also see how the propagation then with 1.5 meter per second of the airflow, constant airflow, along a 160, 200 meter long tunnel took place. And there was no dilution from fresh air that came from another side. So now to first of all, you see here again the scenarios now with some real pictures, how we set this up in the closed tunnel and then also in the firing tunnel, in the open tunnel, and the post-mortem picture, how the battery was looking like after the destruction. Now I give back to the regie to put in a small video. It takes about 2 minutes, and then we will continue. So I think this this video or this movie that we took tells a lot. Is certainly very impressive, and we were astonished and also impressed with ourselves when we made the experiment. It was very exciting experiment, you can imagine. Now, in the analysis, as I said, we have selected a lot of data, and basically what you see, well, if the thermal runaway of just the module already takes place, and don't speak about the full battery, if this in a total would start, this fire source is really strong and the effect is spectacular. We also see that there are high temperatures that lead to the vehicle fires, but, and that's the good message at this point, a vehicle fire remains a vehicle fire. So the standards that are set, they fully apply, they don't need any change. So there's no change expected in the design and the expectations. However, where we see a difference clearly is the emission of special substances. And in particular, in the closed environments, you see here the comparison of internal combustion engine vehicle, standard vehicle, traditional vehicle, compared to a battery electric vehicle in the closed case. And these are atypical emissions that we find, and they need or require a special consideration. How about the environmental risk by the air pollution? Well, we see compared in the closed environment experiment to the open environment where we had the air ventilation, of course, there is a high dilution of these emissions, and they are propagated also along the tunnel, and of course diminishing the far away that you go. However, the amounts that are detected are still considerable, and there remain persistencies also over years. So the experiments we did 2 years ago, in this experiment, we studied at the beginning also, and we still found significant amounts of this material, which ask, and we analyzed this also in the experiment, after such events or such accidents, you need to have a proper cleaning. The good news is, if you do the standard cleaning as you do in the case of an accident with fire in a tunnel, you can really clean it. Afterwards, you won't detect. So in comparison to a new tunnel or to a regular tunnel, the amounts then are, or the residues are not found anymore. So this is definitely possible. What you see, the environmental risk, there are critical loads. So in this table, please apologize for the German, in the full report is in German, but you see cobalt, manganese, nickel, and lithium. These are amounts that are found, be it in the cleaning water, but also in the cooling water, in considerable ways. And they are clearly detected, and so there is a need to have a pre-treatment of the water in use, be it the extinguishing water, be it also the cooling water itself when you get rid of the vehicle after the fire. So the recommendation is clearly to consider the use of road wastewater treatment plants. We see there are also environmental risks for the cooling water, as I mentioned, because standard methods to keep the thermal runaway under control is to cool this extremely down. And we found in the extinguishing water pH value compared to standard water that is in use was not changing to the reference. Negligible increase of the electrical conductivity. However, if the car or if the battery itself is cooled down and kept in the cooling water, this is over time significantly changing towards very high pH value, and also the electric conductivity is extremely increasing. So this also shows that there are new risks that have to be considered and should be harmonized in the requirements accordingly. So for the result, what happens? Battery-driven electric vehicle fires with lithium NMC batteries in closed rooms, they will lead to a partially atypical emission of cobalt, nickel, manganese, the core cathode elements, as well as fluorides and lithium. And this is unlike in standard vehicles. They increase the toxicological risks. For example, this needs to be considered for the decontamination works. It can be decontaminated, but needs to be considered that these elements are present and stay also present. And this makes also relevant that differentiation is made between extinguishing water and cooling water and the treatment thereof. As a result, pre-treatment of the wastewater is absolutely necessary. The second thing, what we also can say, what does not happen, in closed rooms, this will not lead to critical contamination in large ventilated infrastructures, causing an essential change in the accident management. So it will not change a lot in the standard procedures that are already established, how to behave in the case of an accident, and lower the value of available. They will not lower the value of the availability for the facility. So keep following and implementing the state of the art. That's the important thing. Do what is required in the proper way, and don't take this too easy. This, I think, should be taken into consideration. Now, as a result and recommendation of measures, the project came up with 6 points, and I think basically the first 2 are the most urgent ones. This means mandatory. It should be mandatory to have a retention and a professional disposal of the extinguishing water in accordance with the applicable regulations. And also the definition of safe handling of cooling water and urgent practical implementation is an absolute must that in the future should be better described and implemented in all the procedures and requirements. With this, I already come to the end of my presentation. I hope you enjoyed it and you can take some good deliverables with you. In case of questions, I'm available. You can also reach me under my Hagerbach address, and I certainly invite you also to follow our current activities of the next 50 years of Hagerbach. Thank you very much for your attention.
Thanks, Michael, for your great presentation. It was a really interesting story and also very impressive videos to be seen of your tests. I've seen here indeed questions in our Q&A live part
Yes.
here. So one is, have there been more tests based on other battery chemical composition types like LFP, NMCs, etc.? So did you do many different types?
No, the battery that we used, that was important for us also to use the same battery as we did in the first experiment 2 years ago. So we used exactly the same also to have the comparability and to check the persistencies that we already have, and then to have a closer analytical approach by the EMPA not only on the tunnel wall itself, but also on the closes, for example, of the emerging forces. And we also saw there you can perfectly clean this and get rid of the contaminations also from the closes. And this was done in a very systematic way, based on the same battery type, which was this lithium NMC battery.
Okay, thank you for that. Next question is about the cooling water. Could you please explain what is meant by cooling water?
Yeah, one thing is you have the extinguishing water, that is clear. You have a fire, then you extinguish the fire. The cooling water is typically where you put the battery in to control the temperature of the battery itself, as long as there is a thermal runaway. That's once the thermal runaway of a battery starts, you cannot break it down. The only thing you can do to get the best control is to cool it strongly down. But we saw this in several tests and other research. As soon as the temperature is rising, the thermal runaways continue. So that's one important topic, how to completely eliminate the risk of the thermal runaway, how to make sure that the thermal runaway is 100% closed. In our case, we destroyed the full battery with all the cells. Of course, in other batteries, if you just start with one cell, then can come the next cell, the next cell, the next cell. This can be a long run. And we saw with emerging forces here in Switzerland also that it can take over a week to get control or make sure that the battery, the electric battery, for example, of a car is 100% stopped.
Thank you. Perhaps one final question, is smoke more dangerous to humans?
Smoke is dangerous, smoke is toxicological, so there is no difference, definitely.
Okay, so thank you for that. I think we have found here and answered a few questions. I think there is, of course, this one remaining questions which should now close the circle about, I mean, what next? What are the next interesting topics to be investigated? How to make sure that the innovation comes then to the end user? So what is your next plans?
Well, I think there are certainly two things that we saw. As I mentioned, this stopping the thermal runaway or making sure that the process is stopped. Are there methods how to fully eliminate this? This needs to be found because the working forces, they want to continue and not wait for days until they can progress with their works. So fast distinguishing ways. So far, you saw these pictures also from Tesla. They are put into a container of water. This is the cooling water, and then brought apart until all these things are stopped. And how to do this in a more efficient and secure way, this is certainly one important topic. The other topic is also in tunnels, in road tunnels, how about the proper extinguishing fixed installed fire protective means by maybe a mist water system that you place. This should be studied in a better way in relation to electric batteries.
Okay, so with that, I think we are at the end of the session and also on the question and answer. I just let you know, shouldn't you see that there are many thanks, clear presentation, thank you for sharing, many thanks, and so on. So thanks a lot. So what remains?
Thanks for my side.
What remains to me is to thank to all of the presenters for your contributions to this very interesting tunnel security session in the afternoon. To conclude the entire thing, we started kind of sharing a vision of future challenges of underground safety and security, including highlighting next steps to be done to build knowledge through research by involving the entire bandwidth of stakeholders and experts. Apart from that, the importance of cybersecurity during the life cycle of a tunnel was elaborated by an example of a living document to be shared with the entire tunnel community. With regards to adding value through innovation and research, the role of regulations and standards was discussed against the background of the last decade's worldwide activities of tunnel fire safety and related regulations. And finally, this impressive report now about electric vehicle fires in underground infrastructure concluded the tunnel safety session by highlighting the importance of contamination analysis as well as decontamination, of course, and disposal of work. So with that, I wish you a very nice afternoon. I hope I can see you afterwards in one or the other rooms where we can meet. Hope to see you then also in the closing event. And thanks a lot to all of you. Bye-bye. See you next time.
Thank you. Bye-bye.